Hi, welcome to my channel Industry 4.0. Today, in this video, I shall present a brief overview of digital technologies that are optimizing plant operations. Please like and share the video and subscribe to my channel. So, let's start the video. Introduction. The increasing adoption of digital technologies made it imperative to showcase how these advancements are enabling refiners and petrochemical producers to reduce downtime, increase reliability, mitigate emissions, and enhance product specifications. What are digital technologies? Digital technologies are electronic tools, systems, devices, and resources that generate, store, or process data. Well-known examples include social media, online games, multimedia, and mobile phones. Digital learning is any type of learning that uses technology. It can happen across all curriculum learning areas. Description: digital technologies have advanced more rapidly than any innovation in our history, reaching around 50% of the developing world's population in only 2 decades and transforming societies. By enhancing connectivity, financial inclusion, access to trade and public services, technology can be a great equalizer. In the health sector, for instance, AI-enabled frontier technologies are helping to save lives, diagnose diseases, and extend life expectancy. In education, virtual learning environments and distance learning have opened up programs to students who would otherwise be excluded. Public services are also becoming more accessible and accountable through blockchain-powered systems, and less bureaucratically burdensome as a result of AI assistance. Big data can also support more responsive and accurate policies and programs. However, those yet to be connected remain cut off from the benefits of this new era and remain further behind. Many of the people left behind are women, the elderly, and persons with disabilities or from ethnic or linguistic minorities, indigenous groups, and residents of poor or remote areas. The pace of connectivity is slowing, even reversing, among some constituencies. For example, globally, the proportion of women using the internet is 12% lower than that of men. While this gap narrowed in most regions between 2013 and 2017, it widened in the least developed countries from 30% to 33%. The use of algorithms can replicate and even amplify human and systemic bias where they function on the basis of data which is not adequately diverse. Lack of diversity in the technology sector can mean that this challenge is not adequately addressed. Types of digital technology. Simple examples of digital technology. Having spent most of my life working in the technology field, one of the biggest challenges technology has is that even though it is often cited as simplifying or improving our lives, it can be difficult to keep up with or understand. Video technologies for working from home. GPS, what 3 words and location? 5G and virtual reality. Smart homes. Cloud and SaaS. Artificial intelligence, AI. Deepfake and AI. Bitcoin and blockchain. Cybersecurity and biometrics. Combination of tech such as AI, IoT, drones, and connectivity. Mobile phone roaming and digital connectivity using eSIMs. Use of digital technology. Digital technology enables the storage of massive amounts of information in relatively small spaces. Large amounts of media, such as photos, music, videos, contact information, and other documents, can be carried around on small devices like mobile phones. As well as physical locations, data can also be stored online, enabling it to be accessed from any device which has internet access. Advantages of digital technology. Digital technology has transformed nearly every aspect of modern life. Travel, work, shopping, entertainment, and communications are just some of the areas that have been revolutionized in recent decades. It's now rare to find an electronic device or piece of machinery that doesn't incorporate digital technology in some way. Digital technology means that devices can be more compact, faster, lighter, and more versatile. Huge amounts of information can be stored locally or remotely and moved around virtually instantaneously. Even the term information has expanded to include media such as photos, audio, and video, and no longer refers to just words and numbers. 16 Digital technology benefits. Social connectivity. Communication speeds. Versatile working. Learning opportunities. Automation. Information storage. Editing. Accurate duplication. GPS and mapping. Transportation. Low cost. Entertainment. News. Warfare. Banking and finance. Smaller sized devices. Now, we will discuss the latest digital technologies being adopted, as well as ways to protect systems from cyber attacks. These systems are not intended to replace personnel but to enhance workflows and increase operator efficiencies. Molecular modeling. A new era of the energy revolution has arrived with the rapid growth of innovative technologies that utilize alternative energy resources such as electricity, solar, wind, and hydrogen, and an increasing demand for sustainable use of natural resources. Refiners are facing unprecedented challenges in maintaining their profit margins. For example, the demand for fuels, especially gasoline, is decreasing significantly due to the widespread adoption of new vehicles that run on various fuels. In the next decade, the refining industry is expected to shift from a fuel-oriented industry to a raw material-oriented industry. Therefore, crude to chemicals is one of the major technology paths for refining operations. Moreover, strict governmental and societal regulations on carbon dioxide, CO2, methane, CH4, sulfur oxides, SOx, and nitrogen oxides, NOx, emissions are pushing refiners to reduce carbon emissions and upgrade to alternative feedstocks, example biomass, pyrolysis oils, together with petroleum fractions. Optimize blending using software. Linear programming, LP, is an optimization modeling technique in which a linear function is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, refineries, and chemical plants. Petroleum refining involving gasoline blending bears a different cost of manufacturing. The proper allocation for each component into its optimal disposition is of major economic importance. To address this problem, most refiners employ LP that permits the rapid selection of an optimal solution from multiple feasible alternative solutions, as each component is characterized by its gasoline blending in petroleum refining. Examples provided in this article are the solver from Microsoft Excel and Lingo software. Product blending plays a key role in preparing refinery products for the market to satisfy product specifications and environmental regulations. The objective of product blending is to assign all available blend components to satisfy product demand and specification to minimize cost and maximize overall profit. Almost all refinery products are blended for the optimal use of all the intermediate product streams for the most efficient and profitable conversion of petroleum to marketable products. For example, typical motor gasolines may consist of straight-run naphtha from distillation, crack 8, from fluidized catalytic cracking, FCC, reformate, alkylate, isomerate and polymerate, in proportions to make the desired grades of gasoline and the specifications. Basic intermediate streams can be blended into different finished products. For example, naphthas can be blended into gasoline or jet fuel streams, depending on the demand. Online blending is more prevalent than batch through optimization programs. In most cases, the component blend nonlinearly for a given property, example vapor pressure, octane number, cetane number, viscosity, pour point, and correlations in programming are required for reliable predictions of the specified properties in the blend. One critical economic issue for refineries is selecting the optimal combination of components for the products. Refining does not provide commercially viable products directly, but rather semi-finished products, which must be blended to meet the correct customer's specifications. Blending is an important operation within the refinery. It is a physical process in which accurately weighed quantities of two or more components are mixed thoroughly to form a homogeneous phase, which can be either similar or dissimilar in nature. Robotic process automation. Robotic process automation, RPA, is a technology solution that has gained popularity for its ease of implementation, rapid deployment, and ability to deliver immediate, measurable results. RPA in the oil and gas industry uses computer software or robots to perform repetitive, rules-based tasks to boost capabilities and save time. RPA is similar to an Excel macro without being limited to use with Excel files. Examples of RPA include opening an email, downloading a spreadsheet attachment, and copying the data from the spreadsheet into an ERP system.